Hello and welcome to this repair tutorial, and today we're going to look at a Teac, and the model number is A-R650, and this is the Mark 1 version. In terms of general specifications, your power output RMS is 120 watts times 2 into 4 ohm speakers, and this reduces down to 90 watts per channel if you're connecting 8 ohm speakers. From the front fascia you have the ability just under the input selection knob to select speaker set A or speaker set B, or both of them, or disengage if you want to use the headphone socket for personal listening, and your impedance there is from 4 ohms up to 16 ohms, but I would reference back to the manual for the correct wiring on the rear terminals and what that maximum impedance would be split between the two channels. And then for input sensitivity, it can support the connection for an MD input, tuner, CD, AV and also the auxiliary, and that would be 180 millivolts. And then for phono input, and this is a moving magnet, then it is 2.8 millivolts at 47 kilo ohms. And then frequency response comes in at 10 Hz to 65 kHz, and then total harmonic distortion is less than 0.02% for an 8 ohm load at 1 kHz for 45 watts. And then the headphone socket is for personal listening, and this is nice because you have a 1/4 inch jack socket, and just on the right hand side you'll notice that you have a microphone input as well, which is kind of unique for the Teac A-R650, and there's also a smaller version which is the A-R630, and then you have the direct mode. So this is where you bypass the tone control circuits, and you also have a mute button, and you have the ability to connect to some external device, and the line output is at 150 millivolts. Overall dimensions, height wise, are 142 millimeters by a width of 435, and then depth of 355 millimeters, and a decent weight for this amplifier, coming in at 9.2 kilograms. Now, in terms of servicing of these amplifiers, I would say, it's a modular construction, so it is quite straightforward. You don't have the sort of the complexity where you have to remove an infinite number of screws just to get inside the unit, or maybe to remove some of the circuit boards. So really, what was the issue with this amplifier when it came into the workshop? Well, when you look at the front fascia, it supports a full remote control unit, and when you press the power button, it's a conventional latching type switch. Once that is engaged, what will happen is the startup circuit at the rear of the amplifier will come into operation, and that provides power then to the microprocessor. And the microprocessor will continuously monitor the status both of the command coming from the remote control and also the secondary push button, which is just below the IR window. And if you press that, within about 5 seconds, what you should hear is an internal click as the startup transformer receives its power via the startup relay, of course, on the startup board. But what you found was that the amplifier just simply made a click sound, and that was the relay just simply operating and then disengaging again, indicating to you that the amplifier was in protection mode. Now, from experience, the amplifier can go into protection mode for a number of reasons, and it may well be, for example, that there could be an issue on the main circuit board, or there could be maybe an issue with the power toroidal transformer. And to actually make the test, or to check this, it's very straightforward. And then what I'm showing you now is the startup board, and located on the startup board is a 4 amp T or time delay fuse, and if you check that, you'll find that it's not blown. So it's not that the amplifier protection system has not operated in a timely manner. It has, but the next thing you need to verify is the large EI transformer working, and that's very, very easy to do. So what you can do is simply, and I've drawn a circle around on the startup board, you can see now that on the main circuit board the secondary of the transformer plugs in. Now when I talk about the power supply, there is regulation on the main amplifier board, but there is also this other board which contains or holds the large smoothing capacitors. And then what you'll find is the secondary connection from the transformer plugs into the board, and what you do is you just simply disconnect it, and then when you then apply the power and try to switch the amplifier out of protection mode by pressing the standby button, within 5 seconds you should hear the relay click, but now the relay will stay energized, and that's indicating to you that the main issue then is on the amplifier board. If you wish, you could make a sort of continuity check on the primary of the transformer if you wish, or if the startup relay energizes, then it will be of course providing power then to the power transformer, and it's a very easy task just to use your multimeter leads just to check the AC voltage to see if the transformer is working correctly. Just just sort of input for yourselves, if you do check the toroidal the power transformer on this amplifier, you'll find that the input resistance is quite low. And also be aware that if you're going to power up the amplifier via the dim bulb tester, and again I've put a link in the description of the video, just be aware that these large power supply smoothing capacitors will take a period of time to charge up. So if it's starting up from cold, you'll see that the amplifier or the series dim bulb tester will light brightly briefly, but it's just a case of just operating the standby button a couple of times, and then the capacitors will then charge, and then the amplifier should, in theory, come out of startup mode and then operate correctly if there's no underlying fault. If you kept pressing the standby button and every time it lit very, very brightly, then that's indicating to you that the amplifier is momentarily drawing excess current, and the protection mode will then operate. So how do you actually get into this unit? Well, once the front top cover is removed, it's simply a series of screws from the rear panel, and these rear panel screws of course will connect to the input RCA sockets, also to the secondary mains power adapter where you can connect other devices, and also the speaker terminals as well. And then what you'll find left and right hand side, there are some small silver self-tapping screws, and then if you turn the amplifier over, you'll see about 6 additional screws which keeps in place that back panel. Once you've done that, it is a very, very easy task just to simply disconnect the multi-core cables, and once you've done that, and as I show here, you can lift out the amplifier board, place it onto the workbench, and then just put the main chassis complete with the front fascia and the microprocessor stroke tone board just to one side. And this is this point about it being very, very modular, dead easy to work on. Now, the most common issue with these amplifiers is that you will find either the left channel or the right channel, or in some cases both, output stages fail. And normally there's a visual indication. You may even, when you open up the amplifier, just get like a small burning smell, and that's associated with certain resistors which will fail because of the excess current consumption. Now, in terms of fault finding, very easy. All you have to do is just to put your meter onto resistance, and then just check between the base emitter and collector of the output transistors, and these are the large power transistors which are bolted onto the heatsink. And as you see here, that the heatsink is reasonably substantial, but you also have a secondary cooling source, so it's not just simply relying on the heatsink. You have a fan. So again, if the amplifier is running under load and the heatsink is getting warm, then this fan will come into operation just to run that stream of cold air through to keep the amplifier in normal operating temperature range. So once you sort of get into the fault finding mode, and the next thing that I'm showing you is the extract from the service manual, and this is for the left hand channel which failed. But what I want to also bring to your attention is just at the bottom here, I've also noted that the right channel also failed, but I've not provided the 2 schematics, just the one. For all intents and purposes they are identical. Now when the output transistors fail, what you will find is that certain resistors will also fail, and some of them you will see and you can see that they have failed, and other ones you will not even be aware, and you will only be able to fault find those by using your multimeter. So this amplifier, and because it's a 650 version, the output transistors are Sanken type, and I've reinforced this point multiple times on the repair tutorials. You really have to source genuine original devices. As I've said, the marketplace is flooded by counterfeit devices, and if you source them and you say, okay, I can get them from a lower price, and this is maybe from a supplier, maybe on an auction website, If you install them, they will fail. And they will fail normally catastrophically, and it will take out additional components. So although you may feel that you can get them at a more cost-effective price, it's going to cost you more long run, and you're not going to be able to get the amplifier operational. Now the good thing is that these transistors are not obsolete or even end of line. So if you're looking to source them, you can get them directly from a reputable component supplier, and they will be genuine Sanken devices. So what I'm highlighting here is a series of red circles just to point out to you which resistors failed on the left hand channel. And the amplifier has multiple stages, so you can see here that we have the pre-driver and then the driver stage, and then you can also see where you can set the bias, but we'll come back to that in a moment. So when the output transistors go short circuit, they will also deliver excess current which will flow through the 5 watt emitter resistors, and these are 0.22 ohm. You will not see anything visually. Only when you remove them with your multimeter will you realise that they're in the K ohms or they're completely open circuit. But again, generally available, no issue then to source them. So you'll need to replace normally both emitter resistors. Sometimes when you get a failure of a channel, you may only see that one of the emitter resistors has failed. I would just advise you just to change both, because the current, until the other resistor went open circuit, will have flown or flowed through the secondary emitter resistor. And then the other part which you will find is that there is R in the left channel, R650, and this is a 680 ohm resistor rated at 1 watt, and that will normally burn up. And what you'll also notice is that the colour coding bands on the resistor are no longer, they don't look correct. It's not that you can read the resistor because of the heat. Then you'll find that these colour codes then just don't represent what they were originally. And the same thing also applies for R536. You'll find the 470 ohm resistor has also failed and gone high in resistance. And then the other two resistors is R532 and R533. And both these are 100 ohm resistors at quarter watt, and I show this later on in the video just for additional photographs. And what I've done is I've just drawn a red circle around them so you can see which resistors they are, and as is indicated you'll see that they're burnt up. And then for the right channel, the failure was less than the left. So of course the two output transistors had failed, so here Q614 and Q616, but with the emitter resistors, you're only looking at R629 and the R628. What you found were that the 100 ohm resistors, which are the base bias resistors, hadn't failed. So there was no reason to sort of replace those. But they were lifted up out of this one side of the circuit board and then measured with a multimeter. Once that was done, the next thing that you have to concentrate on is to set the bias for the amplifier. And for this amplifier, it is set at 5 millivolts. So the way in which you do that is you have a test connector located on the board, and you will then connect your multimeter. You don't connect any speakers, you don't connect any input source, and you set your volume, bass and treble control, your balance, treble and bass control to midpoint, and your volume control to minimum. And you leave the amplifier running for about 15 to 20 minutes, and that's just to stabilize. And once that is done, you're able then to make the adjustment to read approximately 5 millivolts, and this is what I show in the video. What I would say to you is that you're going to have to make up a small test connector. For the right channel, you've got access to the bias connector, and it's easy to maybe use your multimeter probes. For the left channel, it's difficult because what you'll see is that the startup circuit board sits directly above the left channel, and what they've done is they've just provided almost like a cutout hole where you've got access with a insulated trimmer adjustment or trimmer adjuster, so you can make the necessary change. But the measurement, it's impossible to get your multimeter leads in there. So you need to make up the test connector so you can push it into the socket. And then what I'm showing here is just such, and I just twist the wires together to cancel out any noise, because we're only talking about 5 millivolts. And then I will then put the startup board back in place, connect then to the multimeter, and then do the adjustment. Once it's all stabilized and no further adjustment is required, you don't need to power down the amplifier, just hold the leads of the test connector and then you can just pull it and it will come out. And then for me, you know, I use that then to adjust the right hand side. Once the bias has all been set up, then there's no further adjustment then to make. You can check the DC offset if you wish, but for this amplifier, you know, there wasn't any concern. And if there was excess DC offset, then, you know, the amplifier would have tripped into protection mode. Now, a point to reference for all of these Teac series, if you're going to be doing the bias adjustment, just ensure that you have put back in place the back panel. As is common, you will find that there are screws which can connect then through to the common ground connection. And that's also the same, there's a common ground connection on the startup board. So the last thing that you want to be doing is powering up the amplifier, maybe on the bench with the back panel removed and none of the fixing screws in place. If you do that, then unfortunately it will cause damage then to the amplifier. So for this amp, you know, quite a straightforward repair, nothing too complicated. And as I said, you know, once you'd replace the output transistors, the genuine originals, a couple of bias resistors and emitter resistors, and then set up your bias current to 5 millivolts. You know, the amplifier performed very, very well and completed all of its functional checks then. So that really brings us to the end of this repair tutorial. And again, if you have any questions, by all means contact me at audioamplifierservicing@aol.com. and I'll be more than happy to come back and provide you with any assistance that you may require. So, until the next time, cheers, bye-bye.